Hello, you are most welcome. I'm teacher Ivan from WUNNA Educational Services. Today we are looking at the dimensions of a physical quantity, and this is our second lesson. In the first lesson, we looked at what dimensions of a physical quantity mean and how we obtain dimensions of a physical quantity. Please, if you missed, make sure you watch so that we move on the same pace. Before we come to this session, I would request that please subscribe to all our YouTube channels from WUNNA Educational Services, which are Teacher Ivan's online classes, WUNNA e-learning platform, and the WUNNA Kids platform. We also have Facebook pages where we post lesson notes and topical questions for your revision. That is Teacher Ivan's online class, WUNNA Educational Services, WUNNA Science Discussions, WUNNA Education Initiative, and the WUNNA Kids platform. See you there. In our second session, we are looking at the uses of dimensions of a physical quantity. We looked at two uses, which was checking the validity or correctness of an equation and also deriving an equation using the dimensions. So let us look at one, checking the correctness of any equation. We shall have an example. For instance, if we are given that the velocity is given by the square root of tension times length over the mass. V is velocity, T is tension, and L is length, and lastly M is mass. So how do we check the correctness of this equation? We have two sides of the equation. We have the left hand side and the right hand side. So let us start with the left hand side of the equation. On the left we have velocity. So the dimensions of velocity, remember velocity is displacement over time, which is length per time. Those are the dimensions of velocity. Then we shall come to the right hand side. On the right we have the square root of the tension times length over the mass. So this is the same as the square root. The square root of tension is a force, and therefore it is MA, which is mass times acceleration. Then we have length over the mass. So that gives us the square root of mass. Acceleration is given by length per square time. Then we have the length over mass. So you realize that from here we can reduce the mass. So that will remain with the square root of length squared per time squared. And the square root is the same as length squared per time squared power half. So when we multiply each by a half, reduces the square, so that we get length per time. And we shall compare our results on both sides. On the left hand side, we had length per time. On the right, we are having length per time. Therefore, this equation is dimensionally correct or consistent. That is how we check the correctness of any equation.